All right, geometry. Today we're going to look at inscribed angles and inscribed quadrilaterals. So let's get started. Remember, an inscribed angle is an angle with its vertex on the circle. So its two sides are chords. So the arc that's created from that inscribed angle is called an intercepted arc, and it lies between the two endpoints of the inscribed angle. So to find the measure of the inscribed angle, it's always going to be equal to half the measure of the arc. Okay, so the measure of angle ABC, we're going to take arc AC and divide by 2, or cut it in half. Now, if we have an inscribed angle whose endpoints are on the diameter of a circle, then it creates a right angle for the inscribed angle. Okay, so the measure of angle BAC would equal 90 degrees. Now, why is that? If we look at this arc right here that goes with the inscribed angle, that is a half circle or a semicircle. And what do we know about the measure of semicircles? We know those are 180 degrees. And if we go back to the property of the inscribed angle, we know the inscribed angle, angle A, is always half of its arc. So 180 divided by 2 gives me 90 degrees. Something else we want to look at is if I have two inscribed angles in a circle that share the same arc, then my angles are going to be congruent. So let's look at this diagram. So I've got the measure of angle ABD right here, and its arc is arc AD. Now, angle ACD also shares that same arc, AD. So since they share the same arc and they're both inscribed angles, those angles are going to be congruent. So angle ACD, is going to be equal to the measure of angle ABD. All right? So let's look at some examples together. So looking at the following examples, we want to find each angle or arc measure, all right? So the first one, we've got an inscribed angle, and they give us its arc to be 62. So if the arc is given, we take the arc and simply divide it by 2. And so my angle, WXY, is going to be 31 degrees. All right? Let's try again. So let's look at this angle, angle PQR. So notice that the endpoints of the angle P and R are the diameter of that circle. So we know that this arc measure right here is 180 degrees, and half of 180 is 90 degrees. So angle PQR is equal to 90 degrees. Now, the next one is a little bit different. So it's asking for the arc measure here. So they give us the angle. So we kind of have to work backwards. All right. So if they give us angle ABC is 47 degrees, and we want to know arc BC, we've got to find the inscribed angle's arc, and then we have to go and find the measure of arc BC. So we've kind of got two steps here. Okay. So let's go ahead and find arc AC, because that's going to help me find arc BC. So if the angle is 47, we're simply going to do the opposite of dividing, which is multiplying. And we're going to take 47 and multiply it by 2. That's going to give us 94 degrees. Now, that's the arc's or the angle's arc measure, but we want to find arc BC. Notice that arc AC and BC make a semicircle. And what do we know about semicircles? We know they equal 180 degrees. So if we say 180 minus 94, we will find that arc BC. And that's going to leave us with 86 degrees. All right, so this was kind of a two-step problem, all right, to find the measure of arc BC. So let's keep going with some examples. On this next question, we want to find the measure of angle RST, which is this angle right here. We also want to find the measure of angle RUT. And if you notice, those are both inscribed angles and they both share arc RT. So if I can find the measure of arc RT, I can find both of those angles measures because I know they are congruent. So notice that they give us 3 arc measures. Okay, so RT is missing, but it also completes the full circle. So if we say 360 minus 64 minus 139 minus 75, that's going to give us the measure of arc RT. That's going to give us 82 degrees. So if I know the arc is 82 degrees, to find the angle, I'm going to take half, and half of 82 is 41. So since both of the angles share that arc measure, the angle measures are both 41 degrees. All right, so the next example, we have an expression. Okay, so we've got this angle CDE. It's equal to 8x minus 9, and its corresponding arc CE, is 158 degrees. Okay, so the arc is always twice as big as the angle, or the angle is half of the arc. So if we take 158 and divide it by 2, that's going to give us 79 degrees. So we know this angle measure is 79 degrees. Now we want to solve for x. So we're going to take 8x minus 9, and we're going to set it equal to 79 and solve for x. When we solve for x, we're going to get x to be 11. All right, so right here, again, we're solving for x, but x is not the angle, it's in the expression for the angle. All right, so we're not going to use degrees right here for 11 because it is representing x and not the whole angle. All right. The last one, we've got this triangle inscribed in a circle, but it's not going through the diameter. And we want to solve for x, okay? So x is right here, but we don't know its corresponding arc, all right? So we have to go about this problem a different way. So if you notice, the only arc measure that they do give us is arc XW. It corresponds to angle Y. So if I take half of 78, that gives me 39 degrees. So I know this angle is 39 degrees. Now, going back to what we know about triangles, the interior angles of a triangle add up to 180 degrees. So I know 2 angles measures in that triangle, and then I know this third one has the expression 7x plus 6. So I can combine all of those together and set them equal to 180 in order to solve for x. So I'm going to say 39 plus 114 plus 7x plus 6 is equal to 180 degrees. And when I solve for x right here, I'm going to get x to equal 3. All right, so let's move on to inscribed quadrilaterals. So if we have an inscribed quadrilaterals, any shape that is inscribed in a circle, its vertices have to be on the circle. All right, so notice this quadrilateral, its vertices A, B, C, and D all touch the circle. So if we've got it inscribed in the circle, opposite angles are going to be supplementary. What do we know about supplementary? Angles equal 180. All right, so remember supplementary, that the 2 angles equal 180 degrees. So my 2 pairs of opposite angles are going to be angle A and C. So the measure of angle A plus the measure of angle C is going to give me 180. And then the measure of angle B plus the measure of angle D is also going to give me 180. All right, so let's look at these examples. So we want to find the measure of angle J and K. And so right here, we're just going to find the pairs of opposite angles. So if I want to find angle J, it is opposite of angle L. I know opposite angles are supplementary, so I'm going to say 180 minus 92. And that's going to give me angle J, which is 88 degrees. Now, M is opposite of angle K. So I'm going to do the same thing again. I'm going to say 180 minus 45 this time, and I'm going to get 135 degrees. And that is how we find angles inside of the circle of a quadrilateral. All right, so the next one's a little bit different. We have some arc measures and just one angle measure, so we're going to have to use those arcs to help us. So I am going to go ahead and find the angle that's opposite of angle Q. So that's going to be angle S. And so to find angle S, I'm going to say 180 minus 93. And that's going to give me 87. All right, so I know that angle S is 87 degrees. Now, I'm going to use the arcs to help me. So let's look at those arc measures that they give me. PQ is 126, and then PS is 90. And if we look at those two arcs together, they correspond to angle R. So look at the inscribed angle QRS. Q and S are the endpoints, and those are the endpoints of those two arcs. So we can add those two arcs together, and those two arcs together are going to give me 216 degrees. And so remember, inscribed angles are always half of its arc. So we're going to say 216 divided by 2, and that's going to give me 108 degrees. And that's going to be the measure of angle R. So that took a little extra step, but now we can find P quite easily. We know P and R are opposite angles, so here we just simply say 180 minus 108, and that leaves me with angle P to be 72 degrees. All right, so moving right along, we're going to look at these last two, and these last two are similar. So both of them ask us to solve for x, and they give us an expression. And if you notice, both times, those are opposite angles. So I know opposite angles are supplementary for both of these. I'm going to add the two together and set them equal to 180. If I solve the first problem for x, I'm going to get x to be 13. Remember, we're solving for x, and it's not representing the measure for the angle, so we're not going to put a degree symbol on that. Over here, we're going to have 133 plus 62 minus 5x. And again, it's going to be set equal to 180. All right, and when we solve for x right here, we're going to end up with x is 3. If you have any problems with solving those two equations, you can check the guided notes to see the steps. So this was our lesson over inscribed angles and inscribed quadrilaterals. Remember, inscribed angles are always half of its arc measure, and then opposite angles in the inscribed quadrilaterals are always supplementary.